that the film title points to the U.S. Navy health time bomb of asbestos and mesothelioma.
About 1 billion years or so ago, when time was young, our Earth was a lonely, barren world. Nothing grew on the land. Few things grew in the sea. No bird song broke the stillness. The wind cried. The storm spoke. And within the earth, violent forces were at work, contesting, molding, preparing for time to come. Beneath the earth's thin, constantly changing crust, molten rock flowed and burned under tremendous heat and pressure, striving to find release. When the crust was torn by subterranean upheaval, molten rock spewed upward. In time, millions of years of time, the molten rock in these crevasses cooled and hardened. Then the hardened rock itself was beset by further disturbances that often left it heavily fissured. Theory says that through these fissures flowed hot mineral-bearing waters and gases, and as the Earth spun off more millions of years, they crystallized, and in so doing, formed the most unusual and useful mineral fiber known to man. Largely unseen, seldom recognized, it has played a tremendously important role in the improvement of our standard of living. As you might expect, the Greeks had a name for it. They called it the unquenchable, indestructible stone. They called it asbestos. Unaffected by fire, unchanged by weather, untouched by time's dark captains, rust, rot, and decay, asbestos possesses rare qualities for which it stands alone. So fine are the individual asbestos fibers that it is only through the eye of the powerful electron microscope that they can be properly studied. Even when magnified 31,000 times, they appear delicate, gracefully hiding the fact that they are incredibly strong, stronger than many types of steel wire of the same thickness. At the same time, they are remarkably flexible and highly resistant to most chemicals. Man has never been able to duplicate their fibrous properties for commercial use. The most commercially useful variety of asbestos, called Chrysotile, has been found in widely separated parts of the world. Only Canada, Africa, and Russia have abundant quantities. Less common types of asbestos, such as chrysotile and amosite, are mined mainly in Africa. The world's largest asbestos mine is the Jeffrey Mine at Asbestos, Quebec, so named for nature's magic mineral. Most deposits have a 10 to 25-year life, but this one has been yielding for more than half a century, and even under the pressure of growing demands, it is expected to produce for another 100 years. The more than 500,000 tons of top-grade chrysotile fiber extracted yearly provide nearly a third of the world's total supply. The mining methods used in the vast open pit portion of this mine are typical of modern surface mining operations practically everywhere. By drilling and blasting and digging, it has grown. Pit mining is not the only means of extracting asbestos-bearing ore from its deposits. Another productive way is called block caving. In open pit mining, the asbestos ore is removed from the top of the deposit. In block caving, the ore is taken from underground. As practiced here, each section to be caved is 200 feet square by 400 feet high. Some distance away, a main shaft is sunk from the surface to a depth below the area to be caved. From the main shaft, a tunnel called the haulage drift is driven in the direction of the section to be caved. Then other tunnels, called crosscuts, are driven under the area to be caved and at right angles to the haulage drift. The crosscuts and the haulage drift form a network of underground arteries, much like the streets of a city. Through them run the mine cars. Now another system of tunnels, called slusher drifts, are driven directly below the section to be caved, above and at right angles to the crosscuts. The floors, walls, and roofs of all slusher drifts are heavily reinforced with concrete. Through the roof of the slusher drifts, draw points 17 feet apart are pushed up into the section to be caved. The ore body above the draw points is now drilled and blasted, and the asbestos-laden rock tumbles down through the draw points to the floor of the slusher drift. Now the crab-like slusher drags it to a point over a crosscut, where it falls into the 10-ton mine cars waiting below. The beginning of a long journey. Now crude ore, soon useful asbestos fiber. All traffic is controlled by a central dispatcher through two-way radio and an electric signal system. At the tipple near the main shaft, the cars are dumped, two at a time. The ore roars down a giant chute to the primary crusher on a lower level, and the crude asbestos rock gets its first treatment underground. From the crusher, it will go downward into bins and then a loading pocket, from where it'll be hoisted in 12.5-ton mouthfuls by fast-moving skip buckets that shoot it to the surface. Working underground, the miners utilize the most advanced mining methods, using fast boring drills. In their many different jobs, they are protected and guided by the highest safety standards. Light, power, ventilation, structure, all are important in the daily production of thousands of tons of ore. All are important in protecting the men who do the block caving. From beneath the earth and from out of the open pit, asbestos-bearing ore, crushed and dried, comes by way of conveyors to the dry rock storage shed, where it is housed in great quantities until needed at the mill. 12 stories tall, this is the world's largest asbestos mill, equipped with the most modern refining machinery. Remarkably dust-free, performing every operation of an asbestos mill on a grand scale with extreme precision. Into its air-conditioned immensity, the asbestos fiber comes to be stripped from the mother rock in a series of operations basically typical of those at many asbestos mills. The rock processed and reprocessed to yield the precious mineral asbestos. On a series of vibrating screens, waste particles of rock are shaken from the fiber. Then, sucked up into giant aspirators, it is further husked of its impurities. In this carefully calculated process, the fiber is refined again and again. Finally, to be tested and graded according to its length under quality control standards which demand the best. From crude ore to refined fiber through the magic of man's ceaseless ingenuity. Now packed and ready for shipment to hundreds of different points around the globe. What do you do with the fiber when you get it? How does it contribute to better living? How does it enhance our daily lives? Let's start with our homes. The attractive roof, which protects us against fire and weather, will never rot or decay because the shingles are made of asbestos and cement. Cement could not do the job alone. A cement shingle would break easily without the reinforcing qualities of asbestos. But when asbestos fibers are added, it becomes strong and tough, amazingly so. Strong enough and tough enough so that it can even be made into large, flexible sheets like these. When these fireproof sheets of asbestos and cement are used as the exterior wall finish of our homes, we enjoy the permanence of stone combined with the beauty of vertical accent, so desirable in contemporary architecture. In traditional architecture, colorful asbestos sidewall shingles give us the same permanence and freedom from upkeep expense. Not only new houses, but old houses as well can have the same benefits with remarkable improvement in appearance. And not only outside, but inside as well. Asbestos helps beautify the home with colorful vinyl asbestos floor tile. Tough asbestos fiber protects them against wear. In the cords of household appliances that demand heavy amounts of electricity, asbestos provides protective insulation. And no matter how long little Johnny plays with his electric train, asbestos insulation in the transformer offers similar protection. And when drinking water comes out sparkling clear, an asbestos cement pipe may have helped guard it from reservoir to home. Water mains of white asbestos cement pipe cannot rust. Since this pipe is corrosion resistant throughout, its smooth interior stays smooth. Asbestos cement pipe also provides a health line in carrying off waste from our homes to the street sewer. It is strong, long-lasting, and economical. When we travel, asbestos protects us right in our family car. Every time we touch the brakes, asbestos in the brake lining resists the heat of friction and brings us to a sure, safe stop, and does it time after time after time. Gripping the drums without scoring, even under the scorching heat and crushing force of high-speed interurban bus brakes, no other brake lining is as safe and durable as that made of asbestos. Asbestos goes aloft, too. Whenever we travel on modern airliners, asbestos products contribute to our safety in many ways. When we travel by train, our ride is made faster and more comfortable with the aid of asbestos packings and gaskets, which conserve the power of the mighty diesel engine. While asbestos insulations on steam and water lines contribute to our comfort. At sea, ships of the American Merchant Marine are the safest afloat. No small part in this achievement is played by the non-combustible asbestos panels used to build the walls and ceilings of cabins and public spaces. These panels are both light in weight and structurally strong. On the farm, asbestos roofing and siding help the farmer protect his buildings against fire, against rodents, and against rot and decay. Inside, sheets of asbestos and cement make easy-to-clean sanitary linings for poultry buildings, dairy barns, and milk houses. Asbestos improves in many ways the industrial equipment that makes the countless products we use daily. Asbestos felts help shield the thousands of miles of gas and oil transmission lines against corrosion. The basis of practically every industrial process is heat. On process pipelines and equipment across the nation, asbestos insulations, by conserving heat, reduce industry's fuel bill by hundreds of millions annually. Indeed, it has been progress in asbestos insulation, withstanding higher and higher temperatures, that has helped make possible many of the new processes and new products that improve our daily living. The motive power of industry is also conserved by asbestos. Pumps, compressors, tools, all kinds of reciprocating, oscillating, and rotating equipment operate more efficiently because of asbestos packing. And asbestos gaskets prevent the escape of fluids and gases from a wide variety of pressure vessels. Asbestos friction materials control motion, withstanding the heat, shock, and strain of braking, holding and releasing the drums of cranes, drills, dredges, and other heavy equipment. Asbestos can be made into the thinnest of paper, and in this form is widely used in the electrical industry, enabling transformers, motors, magnets, and other apparatus to carry heavier loads, getting more electrical productivity without enlarging equipment, and thus keeping power costs down for both industry and the homeowner. Asbestos cement ducts are used to enclose the cables that carry electricity underground. Costs are reduced, and we are better protected against interruptions of service. Asbestos fibers can also be spun into yarn, like cotton or silk. Yarn which is woven into strong protective fabrics of various thicknesses and weights. Industry finds wide uses for asbestos in the construction of its buildings, just as the farmer and homeowner do. So do schools, hospitals, and public buildings. Roofs built of asbestos felts bring added fire protection and effectively safeguard the buildings and their contents. Asbestos cement exterior walls provide the freedom from maintenance that building owners want. Rust-proof and durable, they are resistant to chemicals, fumes, heat, smoke, steam, and weather. Inside the building, asbestos movable walls make it possible to change space layouts without a costly loss of time and with complete salvage of existing materials. And asphalt or vinyl asbestos tile is probably the most widely used flooring in business, commercial, and institutional buildings. Yes, products of asbestos fiber make an important contribution to practically every phase of our lives. And through intensive and dedicated creative research, such products are developed. Here, the scientists, technicians, and other workers have at their service modern aids to scientific research, tools to enable them to find still newer, better ways for asbestos to serve mankind. It took millions of years for nature to create asbestos fiber. It was only 100 years ago that a man named H.W. Johns had an idea how it could be made commercially useful. This is how that idea has grown, from one man to thousands of men and women, to mines and factories in the United States, in Canada, and across the sea. We are now in a new age that daily brings forth new scientific realities. Man is moving toward new frontiers, the vast reaches of the universe. It is a realm where unbelievable pressures and temperatures will be commonplace. In the realization of this greatest of all adventures, asbestos, the magic mineral of nature, will be playing its vital role. For asbestos, it's still a matter of time.